Hello, everybody. So today we're going to talk about midsegments and parallelograms. Okay, so first of all, what's a midsegment? A midsegment is a segment that connects the midpoints of two sides of a triangle or the midpoints of the legs of a trapezoid. So here we got a couple pictures. Okay, let's look at the trapezoid here first. Okay, here's my two parallel sides right here. And so this connects, that means these are the legs, QR and TS. So this connects the midpoint because these two are equal and these two are equal. So we connect the two midpoints. This is a midsegment, OP. Okay, over here, a midsegment just connects the midpoint of two of the sides of a triangle. Okay, so M is the midpoint of AB, N is the midpoint of AC. I connect the two midpoints. I have myself a midsegment. Okay. Now, there's a midsegment theorem. There is a proof for it. We're not going to do it right now. But what the midsegment theorem says is that the midsegment of a triangle is parallel to the third side and half the length of the third side. So right away I know that if this is a midsegment, which it is, it connects the midpoints of the two sides, MN must be parallel to XZ. Okay, and I also know that MN is going to equal 1/2 of XZ. So whatever this is, this side here is double, or whatever this is, the midsegment is half. So we can say if this was 10, then this would be 5. Okay, and actually what happens is you can kind of see if you find the midpoint of this side, which is, I don't know, right about there, we'll say. So that this is equal to this. And then you decided that you wanted to connect this to make the 3 midsegments. What you end up getting is 4 congruent triangles inside here. So this triangle right here, this is half of this side, so this is going to equal these two sides. Obviously, this is half of this because it's a midsegment, it's equal to that side. This is going to be half of this, and so it's going to have 3 marks here, and you're going to get 4 triangles that are all congruent by side, side, side. Okay, but we'll get into that more a little bit later. Okay, the midsegment of a trapezoid is parallel to its bases. So we know this. We know that this and this and this are all parallel. And we also know that the midsegment is equal to the average of the lengths of the bases. Okay, so what does that mean? That means here that EH plus FG divided by 2 is going to equal MN. So in this case, it would be 15 plus 27 divided by 2, which would be 42 divided by 2, which would be 21. So I know this is 21 right here. Okay, moving right along. A parallelogram is a quadrilateral that has 2 pairs of parallel sides. We've already talked about this a little bit. Okay, this side's parallel to this side, this side's parallel to this side. Now, our first theorem that we have with regards to parallelograms is that the opposite angles of a parallelogram have to be congruent. Okay, so we've got a parallelogram, like right here, I've got a parallelogram A, B, C, D. Here's my parallelogram in yellow. I want to show that angle 1 is equal to angle 2 and that angle 3 is equal to angle 4. Okay, so here's what we can do is we can put some other angles on here. We could call this, I don't know, 5 and 6 and 7 and 8 And we might need some other angles. So, but we can start with this. We know that since these two sides are parallel, that alternate interior angles are equal. So that tells me that angle 4 is equal to angle 5. Because parallel lines imply alternate interior angles are equal. Okay, now I've also got parallel lines here, so that tells me that angle 5 and angle 3 have to be equal. Angle 5 has to equal angle 3 because parallel lines also imply that corresponding angles are equal. Okay, so if 4 is equal to 5 and 5 is equal to 3, then that implies that angle 4 is equal to angle 3 by transitive property. Okay, so I've shown this one. Now, I could literally do exactly the same thing to show that angle 1 is equal to angle 2. So I'm not going to rewrite this whole thing. I'm just going to say, similarly, angle 1 is equal to angle 2. And I'm done. Okay, so on that one, if I really wanted to prove it, I would say, okay, well, angle 1 and angle 6 are equal because they're alternate interior angles. Angle 6 is equal to angle 2 because they're corresponding angles. Angle 1 equals angle 2 by transitive. Okay. Now our next theorem is that consecutive angles of a parallelogram are supplementary. So I'm joined here by Gidget, who is not normally a math cat, but she's here to visit today. She was meowing outside the door, so we're going to let her in. So on this one, since consecutive angles of a parallelogram, we want to prove that they're supplementary. We need to show in this picture that angle 1 plus angle 4 adds up to 180, and that angle 3 plus angle 2 adds up to 180. So we're only going to do one of these. We're going to show that angle 1 and angle 4 add up to 180, and then we're going to say similarly for 3 and 2. Okay, so here we go. We can put a 5 right here, and we can say, well, angle 4 is equal to angle 5 because parallel lines imply alternate interior angles are equal. So I know that this and this are equal. I know that angle 1 plus angle 5 adds up to 180 because they are a linear pair. Okay, now since angle 4 and angle 5 are equal, I can substitute angle 4 here. Angle 1 plus angle 4 must add up to 180 by substitution. And so now I've proven this one. Okay, now I can just say similarly, angle 3 plus angle 2 equals 180 degrees. And I'm done. I've proven this one. Okay? So I've now proven that in a parallelogram that adjacent interior angles are supplementary. And I've proven that opposite angles have to be equal to each other. Okay? Moving right along. Okay. The opposite sides of a parallelogram must be congruent. Okay, so how are we going to prove that? Well, let's see. I know this, it's a parallelogram, so that tells me these two sides are equal. Okay, so I can say that GH is parallel to KJ. And I also know that GK is parallel to HJ. By definition of a parallelogram. Okay, so since this thing is a parallelogram, I also know that the opposite angles, I just proved this, that the opposite angles have to be equal. So I know that angle K has to be equal to angle H, because the opposite angles, let's not do that. Opposite angles of a parallelogram are equal. Okay, so I know this is equal to this. Okay. Now, let's see. I can do this. Let's draw this right here. I know that I can do that construction. I can connect G to H. Okay. So what we do is we say draw GJ, segment GJ, and that's just construction. Okay, I can do that. Take a ruler and line those up. Now that gives me some other angles as well. Okay, it gives me angle 1 and angle 2, and since these are parallel, angle 1 has to be equal to angle 2 because they're alternate interior angles. Angle 1 is equal to angle 2 because parallel lines imply alternate interior angles are equal. Okay. Now, you see how this side right here is part of both these triangles. So I can do this. I can put this on here and say GJ, segment GJ is congruent to segment GJ by the reflexive property. Okay. Now, let's go back and look at these two triangles. Look what I got here. I got angle, angle, side, and I've got angle, angle, side. So the two triangles have to be congruent. Okay. So triangle GHJ has to be congruent to triangle. Oh, that's terrible to read right there. So we're going to, oops. We're going to rewrite that a little bit better. Triangle G, what was it? HJ is congruent to triangle KGJ by angle, angle, side. And so now I know that I now know that this side has to equal this side. So GK is congruent to JH by CP/CTC. Corresponding parts of congruent triangles are congruent. And then, so that's this one. Okay, and then I can do the same thing. I can also say right here that it's also true that GH is congruent to kj, or jk, for the same reason, CP/CTC. Okay, so this would be equal to this one, and I'm done. I've proved it. Okay, so that was a fun proof. That's a little bit longer one than we've had before. Okay, now I can also prove that the diagonals of a parallelogram bisect each other. So remember, the word bisect means to cut each other in half. So I've got my triangle ABCD, or I'm sorry, my parallelogram ABCD, and I want to prove that AM is congruent to CM and that BM is congruent to DM. Okay, so since this is a parallelogram, I know that those are parallel and those are parallel. Okay, so let's go ahead and put that down. That AD is parallel to CB, and that AB is parallel to CD by definition of a parallelogram. Okay, that gives me a bunch of angles. I'm going to go ahead and write these in here. So let's go, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so I got 12 angles in here. Okay, now, since this is a parallelogram, okay, I just proved something else. I proved that the opposite sides have to be equal. So that tells me that AB must be congruent to CD, and that AD has to be congruent to CB, because the opposite sides of a parallelogram are equal. So I can put these here like this, I can put this here like that. Okay. Now, let's see. So we got to keep focus on what we're trying to do here. We're trying to prove that AM and CM are equal. So I've got those two sides. Oh, I can say that angle 2, well, let's see, angle 2 and angle 6 are equal. Angle 2 is equal to angle 6 because they are parallel lines, imply alternate interior angles are equal. Okay, so that's going to show me that those are equal. So look at this. I've got a triangle here, I've got a triangle here, I've got a side and an angle. Oh, I also know that angle 7 is going to be equal to angle 3 for the same reason. So let's just put that on the same line. Angle 7 is going to be equal to angle 3 because they're parallel lines, and that makes alternate interior angles equal. So these are alternate interior angles here. See how it forms a Z. Okay, so now I've got angle, side, angle. So I've proven, let's do a different color here. I've proven that triangle AMD is congruent to triangle CMB by angle, side, angle. Okay, now if those are equal, or if they're congruent, that means all their parts are congruent. So that tells me that these two corresponding sides must be equal. Okay, so I can say that AM is congruent to CM, by CPCTC. And also using CPCTC, I could show that DM and BM are equal. So I can put that on the same line here. DM is congruent to BM. And I proved it here, and I proved it here. So I'm done. Those are the same. Those are the same. And so I've proven that the diagonals bisect each other. They cut each other in half. So I can kind of clean up some of this. I didn't really need this stuff in here. Actually didn't really need these. So, okay, there we go. So here's our assignment, 4-3. Have fun with that, and I will talk with you guys later.